CalmNight is a wearable-based in-home closed-loop system for trauma-related nightmare intervention, targeting veterans and individuals with PTSD. The system integrates TMR-based therapy with continuous physiological monitoring, nightmare detection, and adaptive intervention. At a high level, our system consists of two tightly connected components: a daytime therapeutic component and a nighttime closed-loop intervention component. During the daytime, the system guides the user through a TMR-based therapy process. In this phase, the system helps the user build a strong association between a specific sensory cue, such as a sound or a smell, and a rescripted, positive version of their nightmare-related dream content. At night, the system continuously monitors the user's physiological signals during sleep. When patterns consistent with a nightmare are detected, the system automatically delivers the same cue that was used during daytime therapy. By replaying this cue at the appropriate moment, the system aims to reactivate the previously established positive memory trace, reduce the intensity of the nightmare, and help the user transition back to more stable and restorative sleep. The system also provides supportive content based on cognitive behavioral therapy principles to help the user calm down and return to sleep more easily after the user wakes up during the night. We will walk through each part of this process in more detail and show how the system functions in practice in the rest of this video. We now move to the daytime component of the system, which focuses on TMR-based therapy. TMR stands for Targeted Memory Reactivation. The core idea is to reactivate a specific memory at the right time, using a carefully paired sensory cue. This approach is related to imagery rehearsal therapy, or IRT, but it is not the same. While IRT focuses primarily on cognitively rewriting nightmare content, TMR adds an additional layer by explicitly building a cue memory association, which can later be reactivated during sleep. The daytime therapy consists of two main phases. The first phase is the rescripting phase, or setup phase. To begin, the user navigates to the Therapy tab in the CalmNight app and starts the TMR therapy setup. An introductory screen briefly explains what the therapy is and how the process works. After the user selects, "Yes, let's begin," the system asks the user to type in a recent nightmare that they remember clearly. Once the nightmare is entered and the user selects "Continue," the system presents two options. The first option is, "I'll write my own rescripted dream." This option is intended for users who are working with a clinician and prefer to manually rewrite their dream content. The second option is, "Let CalmNight AI help me rewrite it." This option represents our long-term vision, where the system can function as a standalone system without requiring direct clinician involvement. If the user selects the AI-assisted option, the system explicitly asks for permission to share the dream content with large language models hosted on secure cloud servers. The interface clearly states that the dream content is used only to generate rescripting suggestions for the user and is not used to train the AI models. Once the user approves, the dream content is securely sent to the cloud, where the system rewrites the dream. After a brief waiting period, the system presents three different rescripted versions. The rewritten versions preserve the core scene or theme of the original nightmare, but transform the ending towards safety, empowerment, comfort, or peace. The user can select the version that best fits their experience. If none of the options feel appropriate, the user can request "Generate new versions" to receive 3 additional alternatives. If the user is mostly satisfied with a version but wants to adjust specific details, they can select that version and choose "Edit Selected Version." This allows the user to freely modify any part of the rescripted dream until it feels right. Once the user is satisfied, they confirm the final rescripted dream and proceed to the next step: cue selection. In this step, the user chooses the sensory cue that will be paired with the rescripted dream. Currently, the system supports auditory cues, specifically short piano chords. The user can tap to listen to each option and select the cue they would like to associate with their rescripted dream. In future versions of the system, we plan to support additional auditory cues, such as spoken calming words, as well as other sensory modalities, including scent-based cues. Before the setup is finalized, a confirmation screen is shown. This screen informs the user that once the setup is confirmed, both the rescripted dream content and the selected cue cannot be changed for the next 7 days. This constraint is intentional. It is designed to promote a stable and consistent cue memory association, which is critical for effective nightmare intervention during the nighttime. We now move to the second phase of the daytime component, rehearsal. This phase is designed to strengthen the association between the rescripted dream and the selected sensory cue. To begin a rehearsal session, the user returns to the Therapy tab and selects Start Practice. The system currently provides 2 rehearsal modes. The first is a guided rehearsal mode, where the system reads the rescripted dream aloud to the user. The second is a text-based mode, where the user reads the rescripted dream silently on their own. In future versions, we plan to introduce a third option, a visual mode, where AI will be used to convert the rescripted dream text into a short video, allowing users to more vividly visualize and remember the dream scenario. We will use the guided rehearsal mode in this demonstration. When the user selects guided rehearsal for the first time, the system asks them to choose a voice. Currently, CalmNight provides both a male voice and a female voice, each designed to sound calm and neutral. Users can tap to preview each voice before making their selection.
Welcome. Let's begin your dream rehearsal session.
Once the voice is confirmed, the rescripted dream content is sent to a text-to-speech model, which generates spoken audio using the selected voice. After a brief waiting period, the rehearsal session then begins. At the start of the session, the system presents a brief introduction, which helps the user relax, calm their breathing, and prepare to immerse themselves in the rescripted dream scenario. Following the introduction, the system reads the rescripted dream aloud. After the dream narration concludes, the system provides a short ending segment, which helps the user gradually shift their attention back to the present moment and the real environment. We recommend that users wear headphones during guided rehearsal, as this helps them hear the sound cue more clearly and reduces external distractions. Each practice session is designed to last 15 minutes. Throughout the entire rehearsal session, the selected sound cue is played every 10 seconds. This repeated pairing is intended to reinforce the association between the dream content and the cue.
Welcome. Let's begin your dream rehearsal session. Please find a comfortable position. Gently close your eyes. Take a slow, deep breath in through your nose. Hold. And now exhale. I find myself in a veterans support group, surrounded by understanding faces. My friend is seated next to me, not as a memory.
After the first rehearsal iteration, the system asks a one-time preference question. The user can choose whether future sessions should include the full sequence or only the rescripted dream itself. The system remembers this preference and applies it to subsequent sessions. When the user completes the full session, the system displays an encouraging message, such as, "Great job," to reinforce consistency and adherence. If the user needs to end the session early, the system still provides supportive feedback. A message appears stating that, even a short rehearsal can help remind the brain of the safer, re-scripted version of the dream. This messaging is intentionally non-judgmental and aims to encourage future engagement. We recommend that users complete 2 practice sessions per day. Ideally, one session takes place in the morning, and another occurs shortly before bedtime. The system can send scheduled notifications to remind users to practice at their chosen times. Users are also free to practice more frequently if they wish. This concludes the daytime component, which plays a critical role in preparing the user and the system for effective nighttime intervention. We now turn to the nighttime component of the system, which focuses on closed-loop nightmare detection and intervention. Before going to bed, the user opens the Sleep tab in the CalmNight app and taps Start Sleep Session. The system then prompts the user to connect the wearable devices used for nighttime monitoring. In the current setup, we use 2 devices, a friend's brainband and a Galaxy Watch. This dual device configuration is necessary because stable and accurate skin conductance measurements cannot yet be reliably collected from the forehead using the headband alone. In future iterations, we plan to consolidate all required sensors into a single headband capable of capturing the full set of physiological signals needed for nightmare detection. Once the devices are connected, the user wears them and goes to sleep as usual. Throughout the night, the system continuously monitors a wide range of physiological signals, including EEG, EOG, EMG, electrodermal activity, heart rate, blood oxygen level, breathing rate, sleep likelihood, body posture, and body movements. The iPad application serves as the central processing hub, or the brain of the system. It receives and processes incoming sensor data in real time. A machine learning model then estimates the likelihood that the user is experiencing a nightmare at any given moment. When this estimated likelihood exceeds a predefined threshold, the system determines that the user may be entering a nightmare state. At that point, the system initiates an intervention. In the current design, the selected sensory cue is delivered through bone conduction speakers on the headband. The cue is played every 10 seconds for a duration of 1 to 2 minutes. The goal of this intervention is to reactivate the positive dream memory that was previously paired with the cue during daytime therapy, thereby reducing the intensity of the nightmare. While the cue is being delivered, the system continues to monitor the user's responses in real time, which includes measures related to arousal and other relevant physiological changes. Once the estimated nightmare likelihood drops below the intervention threshold, or when a significant sleep stage transition is detected, the system automatically stops the intervention. This closed-loop design is intended to support the user in exiting the nightmare without fully waking them up, allowing sleep to continue as naturally as possible. Over time, key parameters, such as intervention thresholds, intervention duration, and cue intensity, are adjusted by a reinforcement learning agent. This adaptive process allows the system to learn the user's individual patterns and deliver increasingly personalized and accurate interventions. During the night, if the user wakes up due to a severe nightmare, the system provides supportive content based on cognitive behavioral therapy principles. This content is designed to help the user calm down and return to sleep more easily. In the morning, once the user is fully awake, the system prompts them to complete a brief sleep diary. This diary includes questions such as perceived sleep quality and whether nightmares occurred. These self-reports help the system refine future detection and intervention, and also provide the user with long-term trend tracking. For users who are working with a clinician, the system can generate summarized reports, which may include sleep quality trends, nightmare frequency, and related metrics. Such summaries allow clinicians to better understand the user's progress and adjust therapeutic strategies to align more closely with the user's needs. In summary, CalmNight integrates dream rescripting, targeted memory reactivation, and real-time physiological monitoring and intervention into a single closed-loop system, which aims to reduce nightmare intensity while preserving natural sleep. Our goal is not only to detect nightmares, but to intervene at the right moment in a way that is adaptive, personalized, and minimally disruptive. We envision this platform as a flexible foundation for collaboration across clinical, research, and translational domains. Thank you for your interest, and we look forward to exploring future collaborations together.